And that takes us very neatly to actually how you go about releasing data. So how you go about releasing your model. And when we're talking about a software engineering system, actually, you've only got one release. It is the live release, effectively. But when we're talking about when we're talking about data science, we have several different ones. We have the alpha release. This is where we release the data into the live world and we test it for accuracy using live data with real users in the live environment. This is going back to the example I talked about where we move from the office environment to a live environment and suddenly we find the cameras are in a different place. Or if we're talking about a different type of data science system where we are moving to a live environment and suddenly our users are using it in a way we didn't expect or a way we didn't predict. And as a result, the model doesn't work. And we go into alpha release expecting the model not to work, for expecting it to have a big hit in performance, for it to not perform the way we expected it to. And that's why we mark this as an alpha release. And it's there to protect ourselves and to say to our customers, say to our clients, we know it's not going to work as effectively as it did in a lab environment. We need to get it out there and see what it's doing and how it's performing so that we're able to then make some changes. You make those changes and then you hit the beta release. This is our effective first release. This is where we are putting it back into a live environment and we're starting to check for what the degree of drift is because we're expected to be far, far less. We can then retrain and re-release. Once it's out there, we then need to hit a period of run and maintain. That is cyclical check-ins to test the model for drift and accuracy. And whereas when we do normal software engineering releases, we release it and we typically say to our client, hey, that's it, off you go. If you get some bugs, send them in. And if we've got a support contract, we'll fix them. And if we don't, then you need to pay for them. In this case, we actually expect there to be drift. We expect the accuracy to decay over time. So we put in place a system whereby we make regular checks on that drift and then retrain the system to do it, to handle that drift. And if you're working with an effective machine learning platform, those can actually be done automatically. A system can be built whereby the degree of drift is checked on a regular basis, and automatically new training systems are put in, are spun up, and the system is retrained on live data to try and close that down, and only comes back and contacts the data scientist if it's unable to improve its accuracy enough. But the point is that run and maintain strategies need to be considered, need to be put in place to ensure that the system performs the way we expect it to. So to conclude, we have an established data science approach, and the established data science approach is one in which we're working with known problems, where we need to agree the degree of accuracy upfront. We need to agree which data models we're using upfront and agree within ourselves, with our data scientists, our ML engineers, what the data looks like, and we need to run a data preparation phase. Scrum works, but we need to maintain alignment between the components within our Scrum team, between the disciplines within our Scrum team, to ensure they are consistently and continuously aligned with our users and with user stories. We need to be aware that not doing this and having stories that focus more on the disciplines will lead to delays in value. And we need to plan for drift and retraining, because even with a pre-established model and established data science system, we're still going to be in a situation where there will be drift and retraining will be needed. When we're talking about experimental data science systems, we are, one too far. We are talking about working with new models or emergent models. We're talking about experimental data science and experimental approaches, and those being inherently unpredictable. So Scrumban is a good way of resolving that issue. To do that, we have to have two teams, but those two teams operate as one team and they deliver as one team, and we need to agree our accuracy up front. As well as that, agreeing what our data models are and how the two teams interact at the data level is highly important, as is running a data preparation phase in order to be able to understand if our data is appropriate to the questions we are being asked on. Upskilling our data scientists and helping them to grow and improve their skills is critically important, as is being awareness of delays to value and using fake data and the API approach we discussed earlier to overcome those. And be aware that you have to plan for drift and you have to plan for retraining. And at just over the 1 hour mark, we are done. Thank you very much for listening. Greatly appreciate you taking the time. If you have any questions or queries, I'm happy to hang around for a little while and answer any that you've got. If you want to contact me directly, you should have my details. If not, I'll put them back on the screen in one moment, and you can reach out and ask any questions or queries that you have if you want to. And there is my contact details. Thank you all very much, greatly appreciated.